This is the Nashorn session. My name is Jim Lasky. I'm the lead of the multi-language group in Java Tools. And this talk is going to be a little bit of background behind this project. It was a little tricky to put together because I was thinking that with an existing language like JavaScript, there's really not too much you can say that would be interesting. So what I'm going to try to do is focus on specific things that Nashorn does that other versions of JavaScript that doesn't do. So our safe harbor slide. So the first thing I'll talk about is the engine itself, the history behind it. Talk about how you would use Nashorn, either directly or as part of your Java code. I'll run through some of the features that are specific to Java, JavaScript Nashorn, and we'll do a few demos, and then finally wrap it up with some final notes at the end there. This is the Raging Red Rhino. That's sort of our unofficial logo. So Nashorn is pronounced Nashorn, not Nashorn, not Nashorn, but Nashorn. This is to pay homage to its ancestor Rhino, which has been on the JVM for a long time. Nashorn is the internal project that was started about 2 years ago, actually 2 years ago in October, to develop an ECMAScript compliant version language to run on the JVM. It started out as an experiment to see how hard it would actually be to implement JavaScript from scratch. It took hold, and the group has gotten a little bit larger in the last 2 years. We're following or tracking edition 5.1 of the ECMAScript standard, but we're also tracking evolving changes in standards. So as new standards come out, we'll be updating Nashorn with the U releases as things change. As I said, Nashorn is a clean database, or clean source base. It doesn't take anything from Rhino. It started from scratch, and it was primarily designed with using 292 as its main basis. It's much smaller and significantly faster than Rhino. And we're tracking the performance of other vendors so that we get ourselves up to the same level as what you're seeing in some of your browsers. So why would we want to do JavaScript? Why would we want to do scripting at all? Well, we find that there's a lot of tasks or applications where it would be appropriate, or seems more appropriate, to do scripting than actually to do a full implementation of something in a higher level language like Java itself. It has a dynamic style. You can do things, prototype things fairly quickly. It's a lot easier to develop something in JavaScript than it would be to start the whole process of developing a Java program. What this JavaScript does that other JavaScripts don't do is that it gives you access directly to the rich Java libraries that are out there. There's a huge number of Java stacks out there covering all kinds of things from networking stuff to embedded system stuff. And we want to be able to access that from our scripting language. So that's the big thing, is that Nashorn talks directly to Java. We chose JavaScript over other languages because it has a fairly similar syntax to Java, but it's very different from Java in the scripting capabilities. It's also, the choice is driven by the popularity of HTML5 currently, and more and more people getting involved in JavaScript. And we hope to attract more developers or newer developers to the platform. So which platforms are we targeting? Well, these are the three main ones that we're targeting initially, but obviously there's other possibilities like in the future. The embedded mobile market, the client side and the server side. In the embedded side, because we're smaller and tighter and faster, it fits quite well in some of the small devices that are out there. Actually, we'll be doing a demo at the end of the talk here. where we're actually running Nashorn on a Raspberry Pi board. One of the things that you should consider about JavaScript versus Java is that JavaScript is a smaller payload because you have a fairly small text item that you can pass around over the network or store in your application. You don't have to download a whole jar. So it works quite well on the in embedded systems. The client, on the client, we're looking at different possibilities. I'll be showing a demo of it, Nashorn using Java FX. There's also a possibility of hooking into WebKit, the web node object in FX. There's currently a project going on where we're trying to integrate Nashorn in. In the slide about the FX, we note that there's a tight integration of Nashorn to Java, and it's really very natural to use the FX from Nashorn, maybe even better than from Java. On the server side, there's already existing stuff that uses JavaScript, JSP. There's business processes that use JavaScript. And there's a couple of other projects on the go within Oracle which are bound in JavaScript. One we'll be demonstrating here later is Node.jar. And Project Avatar, which is server client-side JavaScript. It's to your advantage to think of JavaScript instead of Java as an alternative to Java, because when you're hiring people to do development of server-side systems, it's fairly easy to get people who are working in JavaScript. So if they could work in JavaScript on both sides, then it makes a good investment, for better investment. And one of the nice things too also is that if you think of Java as being a somewhat static system, you have to build your application up well in advance, package it up and download it or ship it to wherever it's actually going to run. The nice thing about JavaScript is that you can modify it once that product is shipped. So one of the things you could consider would be using JavaScript as a configuration language for your field engineers. If they need to reconfigure your application in the field, it'd be a lot easier to tweak up the JavaScript than it would be to mess around with the Java. Just a little bit further on Node.jar. Not a lot of people outside of Oracle really know about this. I just thought I'd bring it up a notch a little bit here. Node.jar is Oracle's implementation of Node.js running under Nashorn. Originally it was started out as a test bed to see if Nashorn would scale up to handle Node.js. But if you know anything about the implementation of Node.js, Node.js is actually a lot of native libraries, a lot of native code. Whereas if it was running in the JVM, it needs to use Java instead. So what we're doing here with Node.jar is actually building up Node.js, but using Java as the underpinnings of it all. Java and JavaScript. So currently we're focusing on the core modules, but then we'll be building up to be able to handle larger units. This is give you an idea of status of the project at this point. We had been focusing on getting our compliance up right from the beginning because we wanted to make sure that we had a good solid version of JavaScript. So that was our main focus. So we had this creed of compliance, correctness, and performance in that order. So we've got to the point where our compliance is pretty good. This was actually the tests. I just ran these on Thursday, so that's fairly current. We're actually only failing one test, and I'm sure by the end of this week or the end of next week, that test will be working as well. So we will meet the compliance requirements of the ECMAScript environment. It wasn't made to. The slide wasn't really made to make the other guys look bad because there are really only 8 or 12 fails, and they're not really anything significant. But it's just to give you a sense of that we're up there with the rest of them. So we're on track to deliver. As I said, we're close to passing 100% in the compliance test, 262 compliance test. Our task now is to harden it up, be able to scale it up to bigger projects, get the performance levels up. So, still have a fair amount of work to do. But since we're shipping with JDK 8, we do have some time to get this right. As announced yesterday, Oracle is planning on proposing Nashorn as being an OpenJDK project, and that should happen fairly soon. So we want people to come on board to help us develop new technologies with Nashorn, and then also make improvements to our existing stuff. So you can think of this as being recruiting to join us. And as I say, we're going to ship with JDK 8. So this is a similar slide that was in the keynote yesterday. We've started talking to different organizations about joining us on the Nashorn project. IBM, NetBeans, Red Hat, and Twitter. So I have a couple people who are willing to come forward and talk a little bit about it. So Sam, you want to come up? So Sam Pallera is with Twitter, and he did a little bit of goofing around on the weekend. we gave him an early release of JDK 8 with Nashorn installed, and can you tell us a little bit what you did with it?
Yeah, sure. So I've known about this project for a while because a friend of mine works on it, and I've been really excited by it. At Yahoo, I built the YQL engine to do its server-side JavaScript performance with Rhino because of the ability to tightly control things. But the actual performance of the Rhino engine is pretty bad. So the first thing I did was play around with Nashorn to render mustache templates using both the default mustache.js library and then also another one created by a Twitter employee called Hogan.js, which basically the idea is you provide a template, you provide it backing view code in JavaScript, and it renders out pages. I was blown away, one, that first of all, everything just worked. There were literally, I never ran into actual a correctness bug with the Nashorn stuff, which I guess that that bears out their compliance with 262. And then on the performance side, it was in the most challenging test, it was more than 20 times faster than Rhino. And I imagine having actually written some invoke dynamic code for mustache.java and knowing how what's left there to capture, I think we're going to see some pretty amazing performance from these guys.
Good. Thank you, Sam.
Yeah.
Also like to ask John Ciccarelli to come up. John is the Director of Engineering for NetBeans. Yeah. So we've had a long relationship with NetBeans. They were one of our earliest adopters, and maybe you can explain what you guys did with it.
Sure. So how many people saw the project easel demo at the keynote last night? You guys check that out? Cool. Yeah, we were very excited to roll that out. It's our new initiative for HTML5 JavaScript CSS tooling inside the IDE, and specifically hooking it up to Java services in the back end. And we completely rewrote our JavaScript editor support off of our old infrastructure, and we rewrote it on top of Nashorn. Don't know how many of you know, but NetBeans actually uses Java-C as a library to provide all of our Java editor features. So you always know that when you get an error in the Java editor, it's the exact same error that the compiler is going to give you. But we do the same thing with Nashorn. We use Nashorn to go through, parse the pages, and provide things like, simple things like indentation and code coloring, to more complex things like refactoring and code completion. It's really helped us because, as we all know, JavaScript is a notoriously hard language to build a structure of. Because it defies structure so much. But we've been able, using Nashorn, to really build a pretty intelligent editor that learns as you type. Right, so as you are creating JavaScript, let's say objects, it'll recognize the patterns and say, oh, hey, that's an object, and provide you the correct code completion and so forth with it. So we were really interested in getting off of Nashorn for a lot of reasons, performance, legal, and so forth. Performance was a huge reason. People are very sensitive to the time it takes to scan a project. When you first open up that project and you get that, hey, scanning, please wait, yeah, and you got to wait for it to scan and scan and scan. Well, scanning the JavaScript files with Nashorn, with Rhino was actually one of our biggest bottlenecks. And so we were, I have to say, when we started, we were a little bit worried about performance. That was the number one thing that we were worried about, and you guys totally blew us away as well. And then the other thing we said, wouldn't it be great to have an in-house thing, because boy, we always need to patch these things, and there's always bugs that we need to work around, and there's always these things that we need to do to kind of get around it. And so it'll be nice if it's in-house, because then we can, work with it as we want. But I'm pleased to say we haven't had to apply a single patch except for a little one to let it be run on JDK 6. We haven't really had to do anything to it. We've been able to use it outside of the box. So it's been a pretty fantastic experience.
Good. Thank you, John. Yeah, as John said, describing about the parsing of the JavaScript language, JavaScript is a very painful language to implement in a lot of ways. So, okay, so how do you use Nashorn? One of the probably more obvious ways of people using JavaScript as a tool, you would use a command line interface. So we have this command line interface that we'll be shipping with it called Nashorn. You can use it in interactive mode or execute a file. But in actual fact, this is just a shell to the way Nashorn really works underneath. And that's using JavaX script. Now, there was a talk just before this one. I don't know if anybody here attended that, but a guy from IBM was talking about the use of JavaX script. If you use JavaX script to initiate your Nashorn session, you can do a lot. You can create your own shell specifically for your task, or you can actually embed JavaScript right in your application. So if you have a text editor application and you want to use JavaScript as a way of reformatting the way the text is laid out on your page, this is how you could do it. It's really very straightforward to use. If you should look at JavaX script in detail. It also gives you ways of binding to Nashorn objects, so you can actually read and write properties of objects. It's a fairly powerful tool to work with. So I want to talk a little bit about the implementation of Nashorn. Nashorn is actually one of the driving forces behind it is that we wanted to fit in well with the Java world. We wanted to make it use as much as Java as we possibly could without actually having to going off and reinventing things. It's been a big advantage to us because the thing is that we were able to pull up a working version of JavaScript fairly easily by leveraging Java fairly well. But it has also made it easier for Java and JavaScript to talk to each other, programs to talk to each other. Objects and arrays within JavaScript or within Nashorn are actually a fairly high-level object that's actually ongoing. There's ongoing changes in the implementation. So they're somewhat opaque to Java users, but it's fairly easy to access the properties by using the JavaX script binding mechanism. Internally, arrays, you use primitive arrays, so you should expect good performance, similar performance to what you would get from Java. We're experimenting with tagged arrays. As you know, if you've used JavaScript, it's an untyped language. A variable X can have either an object or reference to an object, or it can have a primitive value assigned to it. So we need to be able to work back and forth. So a tagged array is a way of actually implementing a structure where we can mix pointers and numeric values or primitive values together. Functions are implemented internally using method handles. So we're taking full advantage of 292. So when you call a JavaScript method, it's going to be using 292 to invoke dynamic to get at that the code for that method. String, numbers, booleans, and the primitives are all native. Okay, so if you pass a Java string off into Nashorn, it treats it like one of the JavaScript string, and the JavaScript string goes back the other way. So there's the one and the same. Same with Boolean numbers. Date, regex, and JSON are special. There's special objects for those, mostly to gain performance. But there's accessors for being able to get that from the Java side. As I said, everything was based on using 292 for as much as we possibly could. So whenever you do a getter or setter operation, either by direct property or by using indexing, whenever you make a call, whenever you create a new instance, that's all using invoke dynamic. And what that means is that at runtime, when you're actually executing, that particular section of code can be replaced with whatever we want. Okay. So just to break it down a little bit, say if you had an expression like var x equals receiver dot property. The receiver can be a Nashorn object. It could also be a Java object. It could be a Java Beans object. It could be a JRuby object. It could be almost anything. And at runtime, when we encounter this, we can look at the receiver and say, oh, we have to call this method, or we have to invoke this code in order to handle the situation. We look up the best fit. So in this particular sequence, we have, object is equal to A and B, or property with properties A and B. And then the second step there is we want to access the property B from the object. So this becomes a dynamic call to get the property B from object. So then when that is encountered, we look up the B property in the object and construct a method handle that handles the extraction of that value from the object. So then bind the call site with that method handle. And from that point on, we don't have to do any further lookup. We basically just say, oh, we already know how to look up B from that object. So it's basically becomes as fast as accessing, let's say, a C field from in a C program. We also have to put a guard there, because the thing is, if the object that's coming in changes, we have to be able to deal with that. So if it was an Nashorn object before and becomes a Java object or a Java Beans object, we need to be able to adjust to that. So we put guards in place to handle that. To deal with all of this, we use an existing library that's actually was written by one of the members of our team. The library is called Dynalink. And what it does, what it is a module system that allows you to create units that determine how to do the lookups and the bindings for these dynamic calls. And because we've used this mechanism, it was fairly easy to add Nashorn to look up. Java knows how to look up things on Java objects, but it also has the possibility of looking up things for, let's say, JRuby objects or Java Bean objects, or specific types like how to treat a map object as though it looked like a JavaScript object. So because of this, we can do lookups fairly quickly and fairly easily, be fairly type-specific lookups. We can do value conversions, handle any overloading. Let's say if you have two methods in the Java class, that there's a conflict in the arguments, we can handle that scenario. And you can do some special default handling. Makes it very flexible. So one aspect of this would be something like the no such property, no such method implementation. So what we can do is we can define a special property within the global space here. It could be in any prototype, where we can say that if you can't find the property, this is how instead of giving us an error, handle it this way. So in this case, in the global space, we were saying, okay, we're defining a function that sets the a property is undefined and returns undefined. So you'll never get an error if the property doesn't exist. It'll just always just return undefined. So it gives you that kind of flexibility. Similar sort of thing here with the JAdapter. A JAdapter is an object that you can define how you deal with gets and how you deal with sets. So if you create a JAdapter object, then the property doesn't exist. You can get it to look up that property in a database, as an example, or look for the value of the property on the network. You can adapt it to do whatever you want it to do. As I said, we're tied fairly closely to Java, and so in order to use Java, you need to be able to access packages that are in Java and other classes, or in classes that are in Java. It's fairly straightforward. To get a bare bones class from scratch, you use packages, dot, and then the name of the class. Java, JavaX, and JavaFX are all built in. As globals, so you can access them fairly easily. So if I wanted to get the integer class, or let's say the utility class or package, I can just say util equals Java util. So that gives me the util package. And that's a shortcut that you can use within your code. And if you want to access, let's say, the integer class, you can just say integer equals Java-lang integer. And what it will do is assign the integer class to integer, and you can access it directly that way. There are some Java, as I mentioned before, some Java objects that are one and the same on the Nashorn side. So, for instance, integer, we can use integer internally. So you can create a new integer, and then you can treat it as though it was an integer value, and you can do arithmetic on it. The main thing here is that because of what Dynalink is doing and connecting up with Java, you can treat Java objects as though they were JavaScript objects. So if I want to get the value of function or method from integer, I can just say integer dot, and this is assuming that I got integer class before. I can just call integer dot value of, and then give it the string, and then it will return an integer value. If I want to access the global max value from integer, just integer dot max value, and then it returns the value. Okay. Java subclassing, it's possible to subclass Java objects just by using the notation of new, and then the Java class, and then open brace, and then add whatever properties or override whatever properties that you want to override in the superclass. So in this case, we want to override the run function in the timer task. So we just say property name, run, and then give it the function we want to call. So then we end up with a subclass of timer task, which will call this run that we've specified here. We've also set it up so that it handles SAM automatically. So if it's a single access interface, then you can put the function in directly. You don't actually have to construct the object. It deals with it directly, the same as the Lambda functions would. If you're working with a Java array, internally it's handled just like a JavaScript array. You can extract values from it. You can insert values in the array. You can also iterate over objects in the array. So the for loop will automatically allow you to iterate over anything in that array. Actually, will allow you to iterate over anything that's iterable. You can handle Java exceptions internally in your JavaScript code. Actually, this is probably not a good example. A better example would have been, I could actually say catch instance of file not found exception, and it will be able to deal with it. This is a tool that allows you to import a whole bunch of packages all in one fell swoop. It's Java importer. And once you've imported all those packages, then you can use the with statement to actually apply against code within the brackets there. So in this case, HashMap is a member of the Java utils package. So you can access it directly that way. And finally, one of the features we added fairly early on was the ability to write shebang scripts, style scripts in Nashorn. So this allows you to throw away your Perl and your Python and whatever else you write in, and actually write things directly in JavaScript. So we added the features of pound comments, being able to access line args and environment args. You can load other scripts into your script, and you have here strings and be able to do edit strings from within the environment. Okay, so at this point, I'm going to do a few demos of some of the things I talked about. Just ignore the transition here. Okay. Yeah, I think that's probably okay. Can everybody in the back see these screens fairly well? Okay. Okay, so the first example I want to show is, since Sam mentioned Mustache, we were just sort of scrambling around trying to find some examples that we could demonstrate, and Sam was quite interested in Mustache because he had done Mustache.java. So that came up, and we said, well, how are we going to make this work for him so he can go off and do this testing? And so it was pretty straightforward. It wasn't that hard to do. So this is what a mustache input would look like. It would basically be these mustaches around substitution areas that in the text that you want to work with. And then you would also provide, well, it's basically effectively a JSON type thing. A way of actually generating the values that are used in the mustache substitution. So in order to get this going, what we did was just created a little shell. We could have probably, if we tried hard enough, we could probably have done it through the Nashorn command line. But we just implemented a little shell here, which all it does is, let's a sec here. I just want to hide the navigation bar. Whoops. Hide the toolbar. What is it I'm trying to hide here? Hide files. Good, thank you. Here we go. Thank you. Okay, so basically this just sort of wraps it all up for us. But the interesting parts of this is that we have we get a script engine manager, and then from the script engine manager we get ourselves an instance of the Nashorn script engine. So from that point on is our engine that we're working with. And in the body of our code here, we fetch a string, mustache string, which is basically to load mustache source code, and then we evaluate the clear cache, and then further on we load the files that are of our template and data, and then execute it. So, just to prove that we can actually execute this, if I can bring up worksheet. Okay, so I'm just going to see if we can do this. It's going off and executing JavaScript, and there it executes and fills it in. I'm assuming that Sam's benchmark was a little bit more complex than that, obviously. Okay. Oops. And so I'll just hide. And, okay, the next example I want to show you is this. This one is a little bit more complex. This is actually built on JavaX, FX. I was running through the examples of JavaX to implement, and there's lots of cool things, and I think you all understand what's going on. But I thought the one that just sort of was, glitzy but not too complicated, so that we could actually do it, was the fireworks example. What the fireworks example is we'll just run it, and then you can see exactly what's going on here. Okay, so the fireworks example is basically just a picture in the background and then drawing fireworks across the screen. But the interesting thing about this one example is that each one of those particles is a JavaScript object, a Nashorn JavaScript object. So the actual glowing and the movement and everything is all done in JavaScript. Okay, now again, we probably could have done something from the command line, but again, we wrote a shell. It's a similar sort of thing where we would create a new manager, script engine manager. Then we ask it to create an instance of Nashorn. And then further on here, we would actually read a file that we execute. So it's reading a JavaScript file that we want to execute. And the JavaScript file is this one here. So this is basically the FX program, all written in JavaScript. And towards the bottom here is something fairly interesting. I think that this sort of, whoops. Okay. To sort of give you a sense of what you can do, this is using the subclassing. So we want to create a subclass of Java FX application, and we need to override the init, the start, and the stop function. So this is how we do it. So this is the sort of the driver for our actual application. What I also think is fairly interesting about this application is originally it was written in JavaScript. It was sitting in the Google JavaScript library. But then the FX team took it and converted it into Java to run as their examples. But then what we did was we took the Java and converted back to JavaScript. And it looks fairly different than the original JavaScript. I did a little bit of a compare, but most part the logic is fairly much the same. One of the things that you should note here is because we recognize beans, there's actually no child property in root. It doesn't actually exist. There is a getter, a get child, and a set child in that class. But because of the way we've implemented Java beans, it says, okay, I don't see a child property there. Let's see if there's a beans accessing mechanism there. And we'll take advantage of that. So you can write your JavaScript code fairly naturally. You don't have to worry about the beans conversion. It's all happens for you. Okay, so the next demonstration is Nashorn running on a Raspberry Pi board. So do you want to take it over?
Okay, can we switch the display? So here we are.
Dave, good. See if you can get the mic on.
Yeah, mic is on. Yeah. So here is the Raspberry Pi. Like later on, you guys can come and take a
you have
look.
to talk into the microphone.
Okay. And here
There you go. Okay.
I did I SSH'd into the Pi. You can see that this is running 7U6 Java SE embedded. And and I just started this Node.jar with a program called Fortune that I wrote, which is a Fortune server. And I'll show you the source code for that. It's very simple. It just forks the Fortune command, takes its output, and pipes that output to the HTTP response. And we can connect to it from the browser, and you'll get some random Fortune every time. So this Fortune program is just a standard Node program. Here is another one which is a little bit more complex. We kill this guy. Oops. And this is a date server. So this program calls into Java to get the current date. It formats it using another Java call, and then sets up a timer. Every 1 second, it writes out the current date to the client. So the idea here is that you can call into pretty much any Java API seamlessly, and then stream the results back to a client. It takes a little while to start up. And I'll show you 2 clients connecting to it. One is this curl. It's not ready yet. There. So now it's ready. And here you get the current date, and you get the same thing when you the browser. The browser ends up caching a few responses, so this shows up in a little while. Basically, the idea is you can call into any this Java API that it's calling into. It could be a JDBC API or any other enterprise Java API.
How many lines does it have to cache up? There you go. Okay, good.
So that's the demo. Okay, that's it.
That's it? Okay, good. Okay, so the point here is that Nashorn is fairly lightweight, so it fits in embedded devices fairly nicely and works quite well. So, okay. Slides again. Yes?
So the Node.jar, is that something that's going to be shipped separately from Node.js?
Yeah, the actual process involved with Node.jar is still up in the air, but it should be, it'll ship separately, but it'll be involved in a different process. So it's not, the current thoughts, well, I can't actually get into it much, but it should be readily available. So. Okay, so.
You also showed it running with JDK7.
Yeah, it runs in JDK8.
If it becomes an open JDK project, will it be targeted at JDK7?
Node.js or Nashorn generally?
Nashorn, yeah.
Okay. So currently we're doing, well, originally we did development on JDK7, but we ran into some technical difficulties that pushed us up to JDK8, but the plan is to get it backported to JDK7. We won't go back as far as JDK6 because that would be technically really tricky to do. So I'll have a Q&A session in a second. Just let me wrap up here. Okay, so just to follow up here is that we have a good solid implementation that plays well with Java. We're tracking the ECMA standards fairly closely, so we're going to try to keep on top of it. So as an example, we have typed arrays sitting in the wings, ready to go in as soon as the standard comes out. It scales to a variety of platforms, runs on embedded client and server. We're going to be making the OpenJDK project proposal very soon, and we plan on shipping with JDK 8. We're also inviting you to become involved with the open source project once it becomes available to help contribute to the environment. There's a couple other sessions involved with the discussion of Nashorn. We have a session that occurred this morning about the optimization code that we're doing inside of Nashorn. There's a Birds of the Feather tomorrow night or tomorrow afternoon for the Java Nashorn team. There's a Birds of a Feather shortly right after that in the same room, I think, for the Node team. Node and actually some EE guys discuss data persistence. We'll also be involved with the polyglot discussion. And finally, Attila is going to be talking about Dynalink in the session on Thursday. Okay, so Dave, if we have the lights up, we're going to have a Q&A session. Okay. Yes.
You showed us that the JavaScript arrays can be represented as a main vector.
I'll repeat the question once he says it. Okay.
So, as usual Java arrays, in this case, how the access beyond bounds is handled?
Okay, so if I have a Java array and I'm trying to index into the array, the invoke dynamic will see, or through Dynalink, will see that it is a Java array, and we'll insert code which will do a Java-like indexing into that array.
And what happens if I access property outside of the length of array?
It will give you an index out of bounds exception.
So it preserves.
It preserves the Javaness of it. Yes. Yeah. Yes.
Yeah, I'm just wondering if there also any attempt to integrate with the rendering engine in the browser, so classic
Yeah. It's that market is kind of wrapped up right now in some ways, but we originally started out as a sort of spin-off from the Java X project, FX project, where they had a language called FX Script, and realizing that it wasn't going to be quickly adopted, we thought, well, maybe we should fall back on JavaScript. So originally we decided that I think of Nashorn as a client, but then as we started going along, we started realizing, oh, this has EE applications, server-side applications. So we started focusing on that more so than on the client side, and this is where Project Avatar and the Node.js kick in. But we're hedging our bets and we're going back the other way. So there's currently somebody poking around and integrating Nashorn into WebKit. So I'm not sure where that project is going to go or how that's going to pan out, but it should be. It's not an easy thing to do because WebKit is massive. We also mentioned here that we're thinking about in terms of writing applications using Java FX, so you could effectively do a browser-like application using Java FX. So it's a little bit further down the road, but yeah, it's a possibility. So
the DOM APIs are...
The DOM APIs are not implemented in Nashorn. We don't supply them, but there are versions that you can download and put in, but they won't do any graphics work. You need to do the graphics side of things, right? So there is a tool out there, and I can't remember what the name of it is, which allows you to run an JavaX script in a browser, and all the output is treated as HTML. So you can actually do HTML type things in that view. So I've seen that around. So yes.
On your first demo, you had a Java FX application written using JavaScript. Every time you see something demo that sort, I always think about the threads. So you can have more than one thread running JavaScript.
Yes. Let's okay. The way we've currently structured Nashorn is that you can have one context per thread. Okay. If you want to run multi-threaded, you'd have to create a separate context, to run it in on a separate thread. So there's no possibility of collision of objects. And if you want the two threads to talk to each other, you have to use JSON to pass messages across. Now that's our short-term goal, and that's the way Nashorn will go out the door. But our long-term goal is to basically focus on that solution, the solution for multi-threading in JavaScript. Okay. Yes?
There was one code snippet where you overrode a Java method with a JavaScript function,
Yes?
assigning it to the simple name of the method.
Yes.
And work with overloaded methods.
I don't know. No, it doesn't. It doesn't currently, right? Oh, yeah, not yet. We don't have a solution for that. The way overloading handling works in a simple call is that you can actually specify the argument types when you're trying to access the property, but we don't have a simple solution to that yet. We're basically trying to handle the sort of the typical case right now, but that's something that we'll have to focus on or work on as we go on. So, yes.
It looks like you've implemented Node's module system. Will require calls use the same heuristics as Node, designed so that you can reuse libraries? Will NPM work natively, or do you have to do a report of NPM in the package manager?
Can you answer that one?
We didn't actually hear the whole thing.
You have to speak up a little bit. I can't hear you.
Will the heuristics for doing a require call for JavaScript dependency work the same as Node that you can reuse a lot of the code that's out there? And will Node package manager run on Nashorn natively, or will you have to do some kind of porting of that later?
Not Nashorn directly, but Node.js can reuse packages that have been installed within NPM.
Okay.
Can load them.
As long as the package is installed, then Node can access it. So, are there any other questions? Yes, sir.
Have you done any benchmarking against other
Yep.
stuff yet?
Yep.
Not going to share that. Right?
Nope.
Should have been to my presentation this morning.
Yeah, it should have been in a session. Okay, so the question is a performance question. I'm not trying to duck it, but the thing is that if we were to actually tell you what our performance is now, it wouldn't really be relevant to when we ship, right? Because the thing is that we have time to move on with some of the stuff. There are some issues in the JVM that we have to work out, and once we work that out, our performance levels should be right up there. And we would actually work quite closely to the JVM team, and we're sort of their. This isn't all software side. It's basically we have to, as far as the JavaScript is concerned, we also have to worry about the JVM and the implementations of things in the JVM as well. So, any other questions? Yes.
I'm not sure if it's relevant if you're not running a browser, but can you sandbox your JavaScript code at the beginning?
Sandbox it in the sense that it runs in a separate.
Well, because you give access to Java objects, like Java I/O, which usually don't have that in JavaScript.
Right. So when you execute, if you're executing multi-threaded, you get a separate context. So there's no cross chatter between the two things, so that they can't interfere with each other's objects. But they're sharing the same memory space, so it's not a true sandbox, right?
The policy file, you can specify permissions in the policy.
Oh, permissions. Oh, permissions.
I'm talking about sandbox and security.
Oh, yes. So there's a permissions file that you can specify the exact.
JavaScript you don't write for files, and you don't open track.
Yeah, no, you can specify whatever you want. It's a very fine-grained security model, so you can basically, right down to the class and that you want isolated. So, yeah, basically you can say all of I/O is basically off limits if you want.
You do have a sandbox.
Yeah, yeah. Anything else? Thank you very much.